So we need to make sure we're developing those numeracy skills, okay? Accuracy and efficiency. We have to balance both, okay? So there's some things that we can do. Sometimes it's just faster to use a calculator. Sometimes it's faster to have that numeracy skill. And there's some things that we can do to reduce that cognitive load and make it a little bit easier, okay? So for example, that first one I started off with some decimals, okay? Not that difficult to deal with, not these huge numbers, okay? I'm fairly confident that most of us should have a decent understanding of how to solve a linear equation, but I want to add in that numeracy and that accuracy piece, okay? So can anyone tell me, some of you may know, especially if you had to be in algebra, I usually tell you how to do this. I don't want to deal with decimals. It's easier for me to process in whole numbers. What can I do to this equation that will get rid of the decimals? Multiply by some factor of 10. Whatever the smallest factor is, that'll get rid of the decimal. So I could multiply by 10, I could multiply by 100, I could multiply by 1,000, and that's going to clear out the decimals and make the math easier to work with without having to rely on technology. So if I multiply 0.6 by 10, what do I have? 6. If I have multiplied 2 by 10, what do I have? 20. If I multiply 3.5 by 10, what do I have? 35C. And then now we've got these nice even integers, not even, but these nice whole integers that we can now deal with a lot more efficiently without having to worry about the decimal place in that alignment. Okay, so now take me on my journey. How do I solve for C? So we'll subtract 20. Okay, so we have positive 20. We want to get rid of it on the right. And so on the left, 6 minus 20 gives me negative 14. And then I still have negative 35C. Divide both sides by negative 35. Because when I divide something by itself, what does it equal? 1. So that cancels it out. I have 1 times C. That's just C. So I'm left with, if I have a negative divided by a negative, the result is always positive. I have 14 over 35 equals C. Is that fraction simplified? No. What's the common factor for 14 and 35 that I can use to reduce? 7. 14 divided by 7 is, and 35 divided by 7 is 5. Okay? And as long as it's a terminating decimal, decimal notation is fine. So if you wanted to write 0.4, you could leave it as 0.4. If you did 14 divided by 35, you'd get 0.4. Most of the SAT is going to be multiple choice, so just find the answer option that matches up. If you found a fraction, but all the answers are in decimals, do the division, you'll get the decimal, and vice versa, okay? If it's a fill in the blank kind of free response style question, usually they will accept fractions or decimals, and they'll explain how to type in your answer, whether you're writing as a fraction or a decimal, okay? So make sure you're paying attention to those instructions. So we got rid of decimals, makes our life a little bit easier. We can do the same thing with fractions, same idea at least. What could I do? I'm going to multiply again. What could I multiply by that will get rid of all 3 of those denominators? 12, okay? So we identify our least common denominator. Just like if we're trying to add or subtract fractions, we have to have a common denominator. Okay, we want to find the least common denominator, but instead of rewriting all of these to have a denominator of 12, what we can do is multiply all of the fractions by 12, because I'll have 12x over 3 minus 12x over 4 equals 12 over 6. Well, what happens if I have 12 over 3? It simplifies to 4x, and then 12 over 4. 3x, and then 12 over 6. 2. 4x minus 3x is accuracy and efficiency. Okay? Ways that we can manipulate the problem to make it easier. All right? Outside of that, we're going to continue with combining like terms and isolating our variable. So here we've got variables on both sides. Okay, so what should we do first? Okay, on the left side, what do we have? On the right side, what do we have? Always simplify the left and the right side first before you start moving from the left to the right. Okay, so would it be easier to move the x to the right or the 2x to the left? Why do you want to move the 2x to the left? Why? Okay, thoughts? That's generally my thought process. Move the smaller one. Move the smaller coefficient. 1 is smaller than 2, so in order to move x to the other side, we have to do what operation? Subtraction. It's easier to subtract a smaller quantity from a larger one rather than subtract a larger one from a smaller one. That way I don't have to deal with that negative coefficient. Because otherwise, if I had the negative coefficient, now I'm adding an extra step later, I have to divide by that negative. Okay? So now that x has been isolated, we end with subtract 3, we get negative 4. Okay? So negative 4 equals x. Okay? 3x minus 7 equals 3x plus 1. Say again? Why? Yeah. Yeah. So once we go and we can see, we'll get equations. You could definitely look in this and be like, there's no way 3 times something minus 7 is going to be the same as if I added 1, right? These expressions are exactly the same. If I subtract 7 and I add 1, there's no way I'm going to get the same value. So we can see logically off the bat, that's a false statement, okay? We can prove it. We don't have to on the SAT, but we can prove it, or if we're unsure, we can verify it. We go ahead and solve. We subtract 3x from both sides, right? It cancels out. We don't have a variable anymore. We just have a statement claiming that negative 7 equals 1. Does negative 7 equal 1? No. We have no variable and we are left with a false statement. These are not equivalent, therefore we have no solution. Okay? So sometimes we can look at that structure ahead of time and make those determinations, and we can see ahead of time, okay, I don't actually need to finish. I can make a prediction on what this outcome is going to be. All right? E. Okay? Now what? Do I have any other like terms I can combine on the right? Infinite solutions, because they're the same. It doesn't matter what value of x I plug in. I will always have an equivalency. 5 times something minus 5 will always equal 5 times that thing minus 5. These will always be true. We can verify it. Again, same process we did above, but notice the difference. My variables cancel. I'm left with a statement claiming that negative 5 equals negative 5. Is that true? Yes, negative 5 does always equal negative 5, which means the value of x does not matter. Therefore, our solution set is all real numbers. Okay? All real numbers. Now, this is a type of question that's fairly common on the SAT. There's a long way to solve it and a short way to solve it, and it comes down to pattern recognition. Okay? So someone give me your thoughts on, you see this problem, what's your approach? What do you want to do? Lennon.
Subtract 1, so 2x equals 4, divide by 2, so x equals 3, then plug in the 2, that's 8x plus 1.
That's a long way. So you want to see a faster way we can approach this? And I'll give you a hint. Look at the relationship between the equation and the expression and find a similarity. It's 4 times as big, right? This expression is this one times 4. So if I multiply this expression by 4, it then becomes 8x plus 4. Well, if I multiply the left side by 4, I also need to make sure that I multiply the right side by 4. And then that gives me 8x plus 4 equals 20. There's quite a few types of equations within the SAT context where they say, here's this equation. Now, what does this expression equal? 99 times out of 100, you can rewrite the equation to look like the expression. You can usually get the sides to match up. And that's really what they want you to do, is find and recognize that pattern. How do I force this to look like this without having to go through all those steps? Now, if you can't figure it out, if you can't see it quickly, then that's fine. Do this. Doing this is better than doing nothing. But if you can get better at that pattern recognition, you can see the connections of here to here. And then if I multiply this by 4 and this by 4, I get my solution. Does that make sense? Any questions on that? All right, let's do inequalities now. Okay, same process, same idea. We just have to remember one extra thing, and it kind of depends on how we look at it. Okay, so inequalities behave almost identical to equations. We solve them in the same process. So what are we going to do here? Okay, so we distribute the negative and we distribute the 3. Okay, left side, what am I going to have? Negative x plus 5 is less than or equal to 7x minus 15. Okay, now inequalities are a little tricky. So strictly speaking, would it be easier to move the negative x or easier to move the 7x? Typically, we would say the negative x, right? Okay, but we have to remember, because now this is an inequality statement, and inequality statements are read left to right. So we need to make sure that we are still interpreting the solution correctly, okay? So from a pure computational standpoint, we want to add x to both sides. We want to add 15 to both sides. And then we want to divide by 8. Okay, 20 over 8 reduces to what? 5 over 2. Okay, so we have 5 halves is less than or equal to x. Okay, so is 0 a solution to this inequality? Would 0 satisfy this inequality? Would 10 satisfy this inequality? Yes. Okay, 0 won't, because 5 halves is not less than or equal to 0. 10 would, because 5 halves is less than or equal to 10. So typically we don't leave the variable on the right in an inequality statement or even an equation. So if this was a multiple choice style question, your options would be x greater than or equal to, x less than or equal to, greater than or equal to, x less than or equal to, and you'd have 4 different number options here based on whatever they put in, okay? And 2 of them would be 5 halves. So 2 of your answers would be this, and then they would probably have 2 different numbers there, okay? So 2 of your answers would be these. Which one of these is it, A or B? It's A, okay? Because x is greater than 5 halves, so we need to make sure that we are reading it properly as x is greater than 5 halves. That's something that if you're not careful will trip you up real quick, and especially when you're under that time pressure and you've got that, that time crunch going on, you need to make sure that it's the little details, okay? That first page that I gave you, that gave you a breakdown, right under, it's the second heading. Most mistakes are not calculation errors. They come from misreading the question, choosing the wrong model, or not interpreting the results correctly. That's where most of your errors are going to come from. All right. Here we have a compound inequality. So we've got two values, or we got two inequality symbols, and we've got three sections. So if let's just ignore this part for now. It doesn't exist. What would I do to solve? Subtract 5, and then what? We divide by -1, right? So I'm going to do the same thing, but because I have three parts of the inequality, I just do it to all three parts of the inequality. When we do the negative, it will, right? So we got the -2 is less than -x, and then we've got 4. Then when we divide or multiply by the -1, we get a +2, inequality switches, -4. And because we switch that inequality on the compound inequality, it's going to kind of flip all the stuff around. 2 is greater than x, which is greater than -4, right? So this ends up getting flipped around as -4 is less than x is less than 2. So making sure we interpret that inequality correctly. We're flipping that around the other way so that it's read from least to greatest. We always read our inequalities from least to greatest, our compound inequalities. Okay. C. Say again. Okay. So we're going to distribute our 2. Let's get rid of that grouping symbol. -2x. What happens? Cancels. I'm left with 6 is greater than 1. Why? Because 6 is greater than 1. Our variables canceled out, and we're left with a statement claiming 6 is greater than 1. That's true. So that means it does not matter what x is, all the numbers work. We'll always have a true statement. So our solution set is all real numbers. Okay. Now, most of the SAT, especially that second section, is set in context. Okay. So again, they're not testing, can you solve equations? All right. There'll be some on there, but once you get about halfway through the section, you're going to see fewer and fewer just equations, and most of what you're going to see is going to be something set in context. So making sure that you can interpret what the problem is setting up, what it's stating, and then make sure you can identify correctly whatever it is they're looking for. They could ask you to write an equation that models the scenario. They could ask you to find a specific value, to interpret a specific value. You need to figure out what specifically the question is asking for, okay? So you can do a quick skim and then focus really closely on what is it asking for you to do, and then work back to pick out the information. Later, in later sections, especially like the data and problem solving unit, they'll give you a giant like word salad block of text, and you don't necessarily need to know everything that's in there. Focus on what are they asking for, and then you can work backwards to find that information, okay? You don't have to decode the entire paragraph. Sometimes they're just trying to get you to waste your time, okay? So we have a car with a price. So the car costs $17,000. You're going to put a down payment of $5,000, and then you're going to make monthly payments of $240. What is this question asking us to do? Very simple, in 3 words. What does it want us to do? Write an equation. Okay. Do I have to solve that equation? Okay. So we just want to look very clearly and plainly, what is it asking for us to do? Okay. We don't need to solve for anything. We just need to write an equation. And this would be a multiple choice style question where they're going to have 4 options there for you to figure out which one works. Okay. Now, given that we have a total that something equals, something that we're paying once, and then something that we're paying over and over and over, what type of an equation would we use to model this scenario? Linear equation. What's the most basic form of a linear equation? The formula for a linear equation. Y equals mx plus b. right? That is our standard outline for a linear equation. Y represents the output, the total, the final amount. M represents the what? No, M represents the slope, okay? The thing that is changing or reoccurring, okay? Also known as rate of change. X is our input value. Often these types of situations, time, and then B represents the what? The y-intercept, which is often our starting point, our initial value, okay? So there's these patterns within the equation. So, Sebastian, what was our total amount? What was our y? It's the 17,000, right? So we've got 17,000, okay, is equal to M. What's our rate of change? Lennon, you said it? 240, okay? Our rate of change is 240. What's our independent variable, our input value? M. That's our input, okay? That's our independent variable. So we have 240 M. And then what is our initial value? 5,000, okay? So we can break down the parts and create our model. We've got a rectangular vegetable garden. What is the question asking for us to do? Write an equation. An equation that does what? Okay, so what's our formula for perimeter of a rectangle? We'll start with P for perimeter equals. How do I find perimeter? We're adding all the sides, right? And we'll shorten that, but we'll start with that, right? Adding all the sides. So how many sides are there? 4. Are they all the same? No. Okay. Are the widths the same? Are the lengths the same? Okay, so I have a width plus a length plus a length. Okay, how can I simplify this expression? Yep, so perimeter is 2W plus 2L. Okay, so that's our outline. But it says write an equation that expresses the perimeter in terms of W. That means I don't want length in the formula. Okay, I want perimeter set equal to some expression where the variable, the only variable there is W. Okay, so they have to tell me something about the length. What did they tell me about the length? 8 feet longer than its width. So I now know that the length is the width plus 8 extra feet. The length is 8 feet longer than the width. So now I can take this L and replace it with this expression. So then that gives me perimeter equals 2W plus 2 times W plus 8. And then we can simplify that equation. We can distribute. P equals, so we'll have 2W plus 16, giving us 4W plus 16. So that gives us an equation that expresses perimeter in terms of W. There's no other variable. We've got the perimeter and just the variable W. All right. Question? All right, peppermint stick pickles. Apparently it's like a favorite treat in Chicago. I don't know. It's weird. You take a peppermint stick and you shove it into a pickle. Okay. Peppermint sticks cost 40 cents and pickles cost $2.30. What is the greatest number of snacks Brian can make if he has $20 to buy ingredients? There's something about this setup that is fundamentally different than the first two. And it's a short little phrase in there. Can anyone pick it out? We used linear equations on the last one. This one's going to be fundamentally different. Greatest number. So that means we're going to be using a what? Inequality. Okay. The greatest number of snacks. Okay. So we're looking at an inequality statement, and we need to then find the answer that satisfies this first. Other than that, there's a couple different ways we can set this up. it still follows the same structure as our linear equation, but instead of the equal sign, we have the inequality. Okay, so we can start with a total, right? What's our total? 20. Okay, he has $20 to buy the ingredients. Okay, so we've got $20. And then this is his total. Then over here, we have an expression that's the cost per pickle, okay, or per snack. So how would I figure out the cost per snack?
40 cents plus.
Yep. So each snack costs 40 cents plus $2.30. And then we can use a variable to represent each snack, okay? So each snack is going to cost how much? $2.70, okay? Now, we talked about greatest number. We need an inequality. So does $20 need to be greater than or equal to this amount, or does $20 need to be less than or equal to this amount? Greater than or equal to, okay? He can't spend more than this, so 20 needs to be more. If this side's more, then he's run out of money. This side has to be less. So we have $20 has to be greater than or equal to $2.70 per pickle. All right, and then we solve, and we get 7.4. 7.4 is greater than or equal to x. So what's the greatest number of snacks that he can make? 7, because he can't make 40% of one. He's going to have an extra pickle maybe, okay? But the maximum that he can make is 7, because 7 is the greatest value that satisfies that equation.